So ultraviolet would be a continuous spectrum.
No, it depends on the cloud. If the cloud is hot cloud, okay, yeah, if the cloud is, it depends on the star, okay. It depends on the object which come in front of the electromagnetic radiation. In electromagnetic radiation, we have all spectrums. It is not like that ultraviolet or radio have separate spectrum.
But you're right.
Okay, actually, okay. So here you will see continuous spectrum. What about position Y?
I don't understand the difference between emission line and absorption.
What?
I don't know what the difference is between emission and absorption.
Last time I told you about the difference.
Yeah, but in this scenario, there is no difference because the eye is just positioned. I don't know. The eye is just positioned separately.
Okay. The word emission. What do you mean by this emission?
The electrons get excited, so they get emitted.
Yes, and absorption?
Absorption is the opposite. They take in, they absorb energy. Give me access to write.
Okay, write it now.
What's the difference between
what's the okay, draw the pattern of continuous spectrum, emission spectrum, line emission spectrum, line absorption spectrum. Okay, I think I need to explain it again. Okay, so if this is the light, okay, you understand what I mean by continuous spectrum, got it?
Yeah.
Okay, so if this is the light, okay, and in front of this light, I am going to place the hot object. Okay, so when I place the hot object, then in this hot object, there are lots of atoms, and inside atoms we have lots of electrons. Okay, and electron have enough energy. Electron already in the excited state. If this is the nucleus, electron is already in the excited state here. Okay.
Yeah.
Yeah. So if you give energy to this electron, so it will jump to the upper shell. Okay. And on de-excitation, it will emit energy. Okay. Got it?
Yeah, this is for emission, right?
Yeah, this is for emission. So you will get line. You will get dark background. Okay, and on dark background, you will get different light, like these lines.
For emission spectrum.
Yeah. So as these are the lines, okay, and these lights come from the emission of light from this atom. So that's why it is called line emission spectrum.
Wait, what do the lines represent? I don't understand.
These lines represent that this is the bright region.
So each line represents the energy shell, right? The energy level, the shell.
Yes. This is a line emission spectrum. So it means that here you will get bright light and here you will get dark light. Like that.
That's yellow, that's pink, that's green light, like that. Different brightness.
No, it depends. It depends on the atoms. It depends on the gas which is present inside. Actually, if electron on de-excitation, electron will emit energy. Okay, electron will emit energy, and that energy is directly proportional to frequency. So it means frequency depend on this energy. So different light have different frequency. Different color light have different frequency.
Okay, so why would the position of the eye change the spectrum that's viewed? Like, how?
Okay, wait, cool down, like this. Okay. Okay, for then, you understand the emission spectrum. Okay, so this is line emission. Line emission. It means the lines is this atom is emitting light, and this atom is emitting light, and that light give me lines. So that's why it is called line emission spectrum. Got it?
Yeah.
Okay, now let's come toward the line absorption spectrum. If this is the sunlight and you place a cold object, okay, so as we know that inside we have atoms, and in atoms, electron will be like, let's say over here, okay, electron is over here. So this electron will consume lots of energy, okay, it will consume lots of energy and will jump toward this shell, okay, and on after millisecond, it will be excited to this shell, and it will emit lots of energy. Okay, so if it emits lots of energy, so it means it will give me like this spectrum.
What? I don't understand.
This is the
Explain. The sun is there, the cold object is there, and then
the inside core object we have atoms. Okay, and inside atom we have electron, and electron is near to nucleus because this is the core object. So this electron will consume lots of energy, lots of sunlight. Okay, so it will jump to a higher energy set. Let's say it come over here. On de-excitation, it will emit energy, and that energy will be greater than this energy.
Yeah.
So it will give me bright light and dark, then bright, then dark, then bright. So as this is a line absorption spectrum, so this is the line absorption spectrum. Line absorption spectrum. It will give me line absorption spectrum. Lines, that is the dark line. Okay, during this region, the light is electron is absorbing light. Okay, so that's why it's called line absorption spectrum.
But the other one is the light emission spectrum.
You what?
The other one is the light emission spectrum, so it's different.
Line emission spectrum. That is the line.
Oh, sorry, line.
Yeah. So line emission and line absorption.
What's the difference? Okay, one is absorbing light, one is emitting light. Okay.
Actually, over here, okay, this light is passing over here like this. Okay. So this light will be absorbed by electron over here. Okay. So more light will be absorbed if it move like this.
But why is it emitting electrons in the downwards direction? Why is
actually here the particles in front of light will be less than this particle or these particles. In this case, lots of particles will come if you pass the light like this and see over here. And in this case, light will come over here and it will come over here and will go into your eyes.
Yeah.
So that's why it is called absorption.
Okay.
Got it. Now let's come toward the oscilloscope. Actually, I discussed all these things last time. But I think your mind, you are mentally absent.
I was so embarrassed. My teacher called my name and I was so confused.
Oh, in front of your friend.
Yeah, in my class.
Okay, I think you are also doing lots of questions, so that's why teacher also asked you. Is that right?
No.
What's about the other student? They also do just like question like you.
You're so rude.
Okay.
I don't know. You can speak to my friends. I don't know. Okay, let's start the photoelectric effect.
Okay, first we need to understand that what is mean by oscilloscope.
Don't hide it.
Oscilloscope. Okay, so in electronics we study the motion of electron. Okay, we study the motion of electron, and when the electron incident on another electron, so how this electron will make a pattern. Okay, it will either it will make pattern like this, either it will make pattern like this, either it will make pattern like this.
Yeah.
Okay. So if you want to see the graph, okay, to see the image of all these patterns, that how this electron will make a pattern. So we see that pattern by using oscilloscope. It gives me a graphical image of the electron motion. Okay. Okay. So in oscilloscope we have three regions. The first one is the electron gun. Okay. It is divided into three regions. The first one is the electron gun. Then after this, we have another, that is the deflecting plate. Then we have fluorescent screen. So let's discuss it one by one.
Wait, what is an oscilloscope? Is it a equipment that will measure the wave picture?
Actually, through oscilloscope, you can measure the time period, you can measure the wavelength, you can measure the frequency, you can measure lots of things. Okay.
Oh.
Yeah,
Okay.
and through oscilloscope, you will see a proper pattern. Okay. If you have oscilloscope, and oscilloscope is like this, I think you see it in your own lab. This is the oscilloscope. This is the screen. Did you see oscilloscope?
Yeah, like this.
Yeah. Okay. And this is your home switch. Okay. And after you study that, the pattern of voltage is sinusoidal. Sinusoidal means like this.
Yeah, I know, sine graph.
And this is the square pattern.
What is the square pattern?
This is square.
What does that show?
This is the rectangular pattern.
Oh my gosh. What is that? And what is that?
This is the triangular pattern.
Oh my god. What is this?
This is this sawtooth pattern.
Oh my gosh, stop it. Oh,
These
I
are
don't like it.
these are the different patterns. Okay. And these are the harmonics. Okay. If this sinusoidal, if your home electricity have noise, okay, then it means there are some sort of harmonics, other frequency which present inside this wave curve. Okay. Okay. So these are the, later on we will study this, all these, that what are these patterns. Okay. So if you insert the plugs of the oscilloscope in this switch, okay, your probe of the oscilloscope in this switch, okay. So after you study that the voltage has a sinusoidal wave shape like this, okay. But here you will have like this x-axis and y-axis, but in this case you will see a pattern like this, graphical pattern like this. If the pattern is not like this, then you will understand that my home electricity have lots of noise.
Oh.
Got it?
Oh, there will be disturbance to the wave.
That will be the disturbance to the waves. Okay, let's say this is the radio signal. No, this is the radio signal. Okay, and the waveform of the radio is like this. Okay, but when your electricity mix with this radio station, this radio signal, then you will get a disturbed wave. Okay, that wave will be like this. There will be some sort of constructor and disturb interference. So you will see this pattern like this. Okay, because this pattern will have this one frequency plus the addition of the another frequency. So you will get a harmonic. You can say that you will get a harmonic wave.
Oh.
Wave which have lots of harmonics. Harmonics with
Oh.
multiple frequency, which we studied in waves.
Oh, first harmonic. Okay, okay, yeah.
Yeah, multiple frequency. Okay, so so on oscilloscope you will see a clear picture, clear graph of your electricity. Yeah, the instrument across which you want to study the wave shape. Did you study about the inductor before? Inductor, capacitor, resistor?
No.
Okay, later on we will study about this. Okay. Okay, so on oscilloscope we study about this, all these things. Okay, we also use the actually that is the electron gun which we use in TV. Any question?
No.
Okay, so this is oscilloscope is made from all these components. Okay, So let's discuss the electron gun. Actually, your oscilloscope is like this. Here we have a electrode like this, and this is the voltage supply. So this electrode will give me electrons through thermionic emission. You know what is mean by thermionic emission?
No, I don't. I've heard of it, but I forgot.
Yeah, thermionic emission is the emission of electron through absorbing thermal energy. Okay, release of electron from an electrode. Release of electron from an electrodes by virtue of its temperature or thermal energy. Okay.
Yeah.
So that is the thermionic emission. So here you will get lots of electron. Okay. But I need that electron. This is the electron gun, which you can say, which use electron instead of bullet. Got it? Gun.
Yeah.
So I need those electrons which have high energy, which move very fast. Okay.
So what's the definition of thermionic emission? I want to write it down.
Thermionic emission is the release of electrons
Release of electrons
from an electrode by virtue
yeah.
of its temperature or thermal energy.
Okay.
Okay, so I need those electrons which have high energy. Okay, I need those electrons which have high energy. So that's why I will place a negative plate over here. A grid, you can say that this is the grid. Okay, this will be negative grid. Negative charge grid. Okay, so
Yeah.
only those electrons will pass this grid which have energy greater than this grid potential.
What? Only those what?
Only those electrons will pass this grid, this grid, which have energy greater than this grid potential.
Oh, okay.
Okay, so those electrons will come over here. But here I will need something which attract these positive charge. So that's why here I will place a grid of positive charge as well.
Oh, is it a photoelectric effect?
No, forget photoelectric effect.
Oh, I thought it's a.
No, that is something else. Actually, photoelectric effect is the release of electron from the metal surface after the absorption of light. Planck says that it will emit electron after the absorption of one photon, but Einstein then said that no, it is not the one photon, it is the stream of photon.
I don't understand what that means. My teacher said the same thing. What is?
Your
So
teacher,
it means that one photon can every electron can absorb one photon.
yes.
Or a stream.
Einstein also said that the same.
So who's right?
Yeah, actually, Einstein explained the wave theory. Planck only explained the particle nature of the light.
Oh.
So that's why Einstein said that not only one photon, light is not, electromagnetic wave is not included only one photon, it is included by the stream of photons. So actually Einstein include the wave nature as well. Okay, later on we will study that. First we need to finish this. Okay, so this is the positive charge plate. So these positive charge plates will attract that electron but we need to accelerate that electron toward over here, okay? Because in TV, you see that in TV, we have electron gun, okay? If you see the TV, so your TV is like this. This is the screen, and here we have a such like shape. Here we use the electron gun. Did you see the TV inside structure of the TV?
Yeah.
So there is something which come outside like this. Like this. This is the screen, okay? You are sitting over here.
Mhm.
And here you see such like shape. Here we have electron gun.
Oh my gosh.
That,
Yeah.
that is a small glass cylinder like shape.
Yeah.
Okay, so in TV we control the brightness. Okay,
Yeah.
so we need electron. So electron will accelerate. Okay, through positive plate positive plate will attract that electron. Okay, positive plate will attract that electron, and that electron, this is the grid. So that electron after attraction will pass this grid. Okay, and when it
Yeah.
pass, so you can say that the electron is accelerated. So positive charge will accelerate these electrons, and different electron will have different speed. So it will strike over here, electron will strike over here, electron will strike over here, and electron will strike over here. But if you increase the brightness, if you want to increase the brightness, then it means you are increasing this potential, positive potential. It means you are increasing the acceleration of this electron, or you can say that you are increasing the velocity of this electron. So the electron will strike at a very high speed on this screen. Okay, so you will get a bright light.
Yeah.
Because in bright light, if we increase the brightness, so you need electron which have high energy.
Yeah.
Okay, so we control the brightness by using the grid potential. You can say that this is the grid potential. Your grid potential will control the brightness of the TV.
Yeah.
Okay, so this is the grid potential. Okay, so if you increase the grid potential, it means you increase the brightness. If you decrease the grid potential, it means you are decreasing the brightness. Now electron will come over here. Okay, so this is the electron gun.
Yeah.
Up to this is electron gun. Now, now let's come towards the deflecting plate. So
Wait, what's the purpose of the positively charged plate?
this grid, positive grid, will accelerate the electron. These electron will pass this grid because this electron have energy that is greater than the grid potential. Okay, grid negative potential. Okay, got it?
Yeah.
But electron will come when electron come over here, so it will confuse that which direction I need to follow. So here I will give a positive potential. So this positive potential will attract this electron. Okay. So it will attract this electron, and you can say that it will accelerate this electron.
Yeah.
So electron will pass inside this, and it will move like this, and it will strike over here on screen. But if you want to increase the brightness, okay, then you need to increase the grid potential. Because if you increase the grid potential, then the positive charge will accelerate this electron at a very high speed.
Yeah.
Okay, so this is the electron gun. Now let's come towards the deflecting plates.
Yeah.
Deflecting plate is divided into two plates. One type of the plate is the X plate. Second one we use is the Y plate. This is the screen, okay? and let's say electron, I am the electron gun, okay? So electron is moving perpendicular to the screen, okay? Think like this,
Yeah.
okay? So electron will come and strike over here, okay?
Yeah.
Second electron will, second electron will come over here, third electron will come over here, and it will strike like this.
Towards the screen.
Yeah. It will come and strike the fluorescent screen. So you will see pattern like this. Got it?
Wait, it will move towards the screen and then?
No, electron will come like this, and it
Yeah.
will strike on the screen. Okay.
Yeah.
Okay. So I need something which change the electron direction. Either it will, if I use deflecting plate like this, and this deflecting plate is positive, then electron will come upper like this, and it will strike the screen. Okay. If this potential is lower, then it will strike the screen.
So it will strike the screen and then what happens?
Okay. If I decrease the potential, if I increase this potential, positive potential,
Yeah.
then electron will strike over here. If I decrease potential further, then electron will strike over here. Okay. So it means this plate is the Y plate. It changed the potential along Y axis.
Okay, I get it. Yeah,
Okay.
I get it.
But I need something which change this direction as well, because I need something which change this direction, because this have two axes. One is this axis. So I got this from this plate. But
That's from the Y plate.
Yeah, that's from the Y plate.
Wait, no, that's from the X plate. It's from the X plate.
That's from the Y plate.
Oh.
Because electron is flowing perpendicular to this Y plate. So electron will move either upward or either downward, either along positive Y axis or either along negative Y axis.
Oh.
Okay, it will move like this and strike the screen, or it will move like this, or it will move like this and strike the screen.
But the electron is changing direction both X and Y.
Yeah, both X and Y. So that's why I will need another plate. That is the X plate.
Oh.
Okay, so I will plate. Let's say this will be the negative plate. Okay. Otherwise, the flow will be like this, because I want to make the flow like this toward this direction, toward positive X direction.
Yeah.
So this is the positive plate. Okay, so it will make the curve toward the positive Y axis. This is positive Y. Okay, if this is positive, then it will move like this.
Yeah.
Okay, and if this is negative, then you will get this curve like this. That will be on the Y axis. That will move like this, but on the Y axis. This pattern you will get.
Yeah.
If this is negative, then you will see the curve 2. If it is positive, then you will see curve 1. And both are moving toward the right side.
What do you mean by negative positive?
Okay, you understand that how I change the position of...
Yeah. I understand how you change the
yes,
potential, but...
by providing Y plates. Okay, these are the Y plates.
Yeah.
Okay, and electron will move like this. These are the Y plates, and electron will move like this and strike the screen. Okay, got it?
Yeah.
Now the question is, either this will be positive plates or this will be the positive plate.
Oh, okay, I get it now.
Yeah, if you make this positive plate, then you will get curve 2.
Yeah, I get it.
And if you, yeah. Now I need something which also apply force in this direction, because I also need something which flow like this, which move like this. So I will provide these plates. These plates is the X plate, X deflecting plates.
Yeah.
So this plate will have which charge? Either it will be positive or negative. This plate.
It will be the opposite of the Y. So it will be.
No.
No, wait. No. Wait. For red curve or green curve? Which one are you talking about? Red curve or green curve?
For both. Both are moving in the same direction, in the positive X direction.
Oh, okay. Right hand side will be right hand side will be positive. Left hand side will be negative, because negative will go to positive. Right hand side is positive.
Okay, so this will be negative. This will be positive.
Yeah.
So electron will come, or here will come like this. Yes. So you will get curve 1. Okay. So it will go like this. It will go like this.
Yeah. Yeah.
But if you give negative charge this, then you will get curve like this. It will move in the negative plate, in the negative.
Yeah.
Okay.
That is a lot of work. Like to make this, it must require so much time and energy to create such a.
No, it's done in the microsecond. If when you plug in the probes, okay, probes of the oscilloscope, you will get pattern like this. Instantly you will get pattern like this. No, it is not like this. You will wait for so much long time. Actually,
Oh.
nowadays we are using processor. When you press the button of when you press the button of the laptop, you will get 0 or 1 or 2 or anything which you want to type over here on the screen, and that is instantly. Actually, nowadays we are using chips, and inside chips we use gates, and gates work on binary digits. And
Oh, that's very, very clever. Artificial. That's very, very advanced.
in 1980s,
Machine learning.
yeah, in 19,
Machine learning.
yeah, in 1980s and 1960s, we use vacuum tube. Vacuum tubes are the big vacuum tubes. Okay, so for one function, you will use this much tube. For another function, you will use this much tube. So that's why at that time, your one computer is covered the full room.
Oh yeah, I remember.
Yeah. and at their time, they hire one person for one button. Okay, one person is standing on one button. Okay, when you need one, yeah, if you want to type A, then you will tell to that person, that concerned person, that press that button. So he will press that button. Then if you want to type B, then you will tell to that concerned person that press button B. So he press button B. So for each button, they hired lots of employees for them. So got it? Got it?
Yeah. Wait, I'm so thirsty. I'm going to get water. Can I get water quickly?
Yes.
Very quickly.
Yes, you can.
Okay, 2 minutes. I'm back.
Okay, so we discussed the electron gun and we discussed the deflecting plates. Now let's come toward the last page of the oscilloscope, and that is the screen or fluorescent screen.
Is this the last topic of waves? Waves topic.
Yeah, this is the last topic. So actually, there is no fluorescent screen. Okay, so we get the electrons. Okay, this is the screen. We get the electron over here, but we need screen like that, which display the image when electrons strike on this screen. So we get a bright pattern. We need such like screen. When electrons strike on that screen, we get a bright pattern. Okay, so here we use the fluorescent screen, and here we use the phosphorus for that. Phosphorus powder. Okay, so here we have powder. So when electrons strike over here, so electron have enough energy. Electron will give energy to the atom of this phosphorus. Okay, to the electron of this phosphorus, and electron will get excited. On de-excitation, after microsecond, it will de-excite and it will release energy. So you will get a bright point over here. Similarly, you will get bright point over here. Similarly here. Similarly here. So in this way, you will get a pattern.
Yeah.
Okay, so like this, you will get a pattern. So we use phosphorus.
What does fluorescent screen mean?
Fluorescent, actually, this is not a simple screen. This is that screen which give. This is the which give me bright pattern. Okay, so you will use phosphorus for that. Okay, so if you sprinkle phosphorus powder on this screen, okay, so when electrons strike over here, you will get a bright spectrum, bright spectrum. You can say that. Got it?
Yeah.
Actually, electron have energy, and electron will excite that electrons of the phosphorus. On de-excitation, it will release light. It will release light, and we see that light. Okay, so let's discuss the photoelectric effect. Actually, after all these bases, you will do that, because hopefully you will do that by yourself. Okay, you will not need any help from me, inshallah.
Okay, hopefully.
Photoelectric effect. Okay, so we have metal surface, and inside metal, as we know that metal is a conductor, and inside this metal we have lots of conducting electrons. Okay,
Yeah.
so this is the electron. Okay, and when I strike a photons on this electron, so now I am striking 3 photons. Okay, so when I strike the photon, so photon will give energy to this electron. Okay, okay, but if the energy of the if the energy, this photon have specific frequency. Okay, okay, and if the frequency is less than specific frequency of this threshold frequency, if this frequency, if the light frequency is less than the threshold frequency, then electron will not leave this this metal. But if the frequency of the photons is greater than the threshold frequency, then it means that the energy of this photon is greater than these electron. Okay, these electron energy. So that's why the photon, these electron will absorb this photon, this energy. That's why these electron will absorb these photons and will leave this atom, this metal. So here electron will flow like this. So as we get electricity, okay, so we get electricity from the photons, okay, through photoelectric effect. So that's why it is called photoelectric effect. We get electricity through photons. Okay,
Yeah.
but there is one condition, and the condition is that your frequency of photon must be greater than the threshold frequency. Okay,
Yeah.
threshold frequency is the property of metal. For all metals have every metal have different threshold frequency, like the resistivity which we discussed last time. Okay, different element have different resistivity. So different metal have different threshold frequency. So when you
Yeah.
strike photons, and photons have frequency, okay. So if the frequency of this photon is greater than the threshold frequency of this metal, then you will get electron. Otherwise, you will not get any electron over here.
Yeah.
Okay. Let's say I am using the quadratic tube, and the tube is like this. We have curved cathode, and here I have anode. Okay, and the tube is, this is the evacuated tube. This will be the cathode, so I will connect it with the negative terminal, and this is the anode, so I will connect that to this. Okay, so light will incident on this cathode.
Yeah.
Okay, this is the evacuated tube. Okay, so when light fall on this, so this is the negative plate and this is the positive. This is negative plate, okay, and this is the positive. So when light fall on this, okay, so we get electrons over here, lots of electrons.
Yeah.
Okay, and this negative potential will repel this electron, and this positive potential will attract that electron, and that electron will come over here. So you will get a current.
Oh. My teacher said that it passes through a vacuum. I thought it passes through a vacuum.
Actually, this is the evacuated tube. Your teacher draw a diagram like this.
My teacher said that the electron will go through a vacuum. Like it will go towards the positive charge plate using the kinetic energy, the excess kinetic energy. So the equation will be like this: work function. Wait, no, E equals work function plus KE. Therefore, KE equals HF minus HF threshold. I can't write it properly, but
Actually, your book is not this. Yeah, this is the equation, but your book skipped all these equations. So that's why I didn't go toward all these equations.
maybe it will come in the next page.
G?
Maybe it comes in the next page.
Yes, maybe. Okay, so this electron will have kinetic energy. Okay, when you apply the potential, okay, so potential will repel these electron. Negative potential will repel these electron. This will attract the positive potential will attract these electron. So this is the potential. Okay, V naught.
Yeah.
Okay, so now I am going to make this negative. Okay, if I make it negative, it means I am increasing this potential. Okay, I am going to switch the, like this will be the positive and this will be the negative.
Yeah.
Okay, so what happened, these electrons, those electrons will attracted by this electron which have high energy than this potential. Let's say this potential V naught. Okay, those electrons will come toward this plate which have high energy than this negative plate.
Yeah.
Got it?
No.
Okay.
Yeah, I don't understand.
Okay, if this is the positive plate, I am going to start it again from the first. If this is the positive plate, okay, this is the positive plate and this is the negative. So this plate will repel these electrons, and these electrons will be attracted toward this plate, okay, positive plates, okay, and electron will come over here, and on M beta you will get a current.
Yeah.
Got it? Now I am going to opposite the polarity.
Why?
Because I want to find the maximum kinetic energy.
Oh, but why do you have to swap the polarity to find the maximum kinetic energy?
Wait. So
I remember my teacher said something like, because the negative charge will build up on the plate, therefore you need to swap the polarity so that, I don't know, I don't remember.
Wait. If this is negative and this is positive,
Yeah.
okay, so this will be negative and this will be positive. Got it?
Yeah.
So only those electrons will be attracted to this plate which have energy greater than this potential, the repulsive force of this, which have high energy than this plate repulsive force.
Oh.
It means that the repulsion is less than the attraction.
So some electrons will flow from here and go all the way back.
Yeah, so you will get current. So now, as you get current over here, so now you will increase this potential. So if you increase this potential, it means you increase the negative potential this and positive potential this. So when you increase this negative potential, so this electron will be unable to come over here because this electron will feel maximum repulsive force because of
But that's bad. Why do you? That's bad. We need lots of electrons to come here. Why? Are you
No, wait. We want to find the maximum potential. Actually, this metal will release electron. Okay, so you will get lots of electron, and those electrons have different energies. Okay, after sun absorption, all these electrons have different energy. So all these electrons are this. Okay, so here all these electrons have different energy. So now I increase the potential, so that's why no electron come over here because of the high repulsive force.
Yeah.
So you will get zero current.
What?
You will get zero current because no electron is coming in this direction.
Then what's the point? That means there's no kinetic energy.
Yeah. No, electron is moving over here, but electron is not coming toward this electron.
Okay, fine.
Okay, so it means your kinetic energy maximum, it means kinetic energy of this is equal to the potential times electron. And this potential, if you increase the potential at which you get zero current over here, then that potential is known as stopping potential.
Wait, repeat that.
Stopping potential is that potential through which you get zero current in the circuit.
How? Because the voltage is too high.
Yeah, because you increase the potential. Yeah, if you increase this potential, okay, you will get high negative charge on this plate, anode.
No, but the current here will be very high here because the electrons will flow like that.
It will flow like this, then no, it will not flow like this.
Hmm. It will. I don't know.
Actually, we do it like this. Okay, this is the positive plate. Actually, the polarity, first polarity was this. First polarity was this. Got it? Sorry. First polarity was this. This is cathode.
Yeah.
Anode. Okay. But later on, I decrease this positivity.
Where? Oh yeah, 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 yeah.
If you decrease this positivity, okay, then you will get, then the electron will not attract it toward this plate. This will repel the electron, and the repulsion force of this will be less, but the attraction force will be less. If you decrease it further, then there will be no attractive force, and there will be no repulsive force.
I don't know if I understand.
Okay,
it
okay,
properly.
wait.
You can explain it tomorrow. It's fine.
Okay, so tomorrow we'll explain it. Okay.
Sorry, we'll go through this whole concept again. Sorry, I just.
Yeah, okay. So tomorrow I will start the photoelectric effect again.